Okay. So by emotion, I mean some aspect of the mental state of a user. Okay, such as you're feeling frustrated, you're feeling engaged, you feel you're facing difficulty programming, or you're interruptible or not interruptible. Okay? And this is a temporary, so it can change depending on the task. And that tries to detect automatically your emotion. And based on 2 projects I've done in this area, one on detecting attention while you're watching a video, and another on detecting difficulty programming, that emotion detection can improve software engineering and also can be improved by software engineering, leading to a good feedback cycle. Okay. First part of the argument, that emotion detection can improve software engineering. So this is a video showing some programmer who's facing difficulty, and that's euphemistically called slow progress, and that is detected by the system. The programmer can correct this if this inference is wrong. Otherwise, the inference can be communicated to some well-wisher who can then start an opportunistic sync to help the person. And you see here the end of the collaboration where Bob is right now thanking Alice. Okay, this is from a real experiment on detecting difficulty. And based on we can generalize to multiple emotions by having Alice deciding to counsel or help Bob, depending on whether the inferred emotion is frustration or having difficulty. And this inference is communicated to her only when she's interruptible. And at that point, she can take the appropriate action of helping. Okay? It's possible that it will be communicated to her much after the emotion has faded away from Bob's head. But at that point, she can do other tasks, such as changing the documentation that led to the problem, perhaps, changing the task, making it easier, maybe checking his code for bugs, just in case the extra difficulty either made him be more careful and have fewer bugs, or made him confused enough that the bugs were high. Okay? So the exact that by detecting emotions, we have many more opportunities for opportunistic collaboration. And the exact set of possibilities is something that I'm arguing, and I think I have a lot of converted people here already, we should explore as a community. Okay? So that's the first part of the second part is, how can software engineering help emotion detection? So you might think that emotion detection is a machine learning problem. And yes, you do need machine learning here. But based on what I've seen so far, none of these techniques really invent a new machine learning algorithm. They tend to use existing implementations, typically of the decision tree algorithm. So if you've got an application that is emotion unaware, such as Eclipse in our implementation, and you want to make it emotion aware, you tie it to some existing implementation of a machine learning algorithm. Okay. You have to tie it though, so you have to write some glue code, and that code is not trivial. Okay. And part of the reason is, this is from our implementation, because we have a lot of, we have some visualization and analysis code built into the application that tries to tell you how the prediction is actually working and to do what-if scenarios with prediction parameters. Okay? And this visualization can involve text, graphics, video. There's no limit to what extent you can analyze what's happening. Okay? This slide is not going to do justice to what exactly is going on, but you can understand that there's many media for visualizing or animating an algorithm. For putting this code is that machine learning is a bit of inspiration. You have to have some ideas of what features you want, okay, some top-down thinking, but it's a lot of perspiration and a lot of iteration where you try something, then you improve it, and you further improve it. So you keep implementing and re-implementing. which means you'd like to be able to reuse your implementations from the previous iteration. And reuse is exactly something that software engineering engineers address. Okay? And we can imagine two forms of kind of generic architecture that allows various components to be changed easily. And it'll be good if this architecture could be emotion independent. Okay? And if not, let's build an architecture for each emotion. And better than an architecture, toolkit that automates the architecture, that allows, that basically has inbuilt support for it. And such a toolkit would be on top of some general purpose machine learning toolkits such as Weka, which is what we've used, and would provide emotion-specific concepts. Okay. So I've made the second part of the argument that software engineering can, very superficially obviously, software engineering can improve emotion detection also. Okay? And I'm ahead of time here based on what I'm seeing there. So that's my point. There's a symbiotic relationship between these two, which has to be explored in depth, or which could be explored in depth. Okay?
Time for lots of questions.
Do you have any evidence as to the usefulness of this emotion detection in actual settings? Have you tried before you had your toolkit?
So you don't buy my argument, top-down thinking?
No, just my curiosity.
So,
the application domain, how much do you know about it?
So I showed you an experiment that was real, and that was from a lab experiment where a person facing difficulty, their status was communicated to another programmer who helped them. And we've also done field use of this. So a student of mine just finished a thesis on difficulty detection, and as part of his requirement, he had to teach a programming course. And he actually built an Eclipse environment which monitored his students' homework. And the first version he created, nobody wanted to use because of some privacy issues. He and an undergrad student fixed those. And by the end of it, almost the whole class was using it, and they loved it. Okay, and is there any reason why you think they shouldn't love it? You were just,
I'm neutral.
okay, you seem like a skeptic.
Would you be able to elaborate a bit on how you detect frustration?
Okay, so there's frustration, there's difficulty, there's attention, there's flow, there's who knows what. Okay, there's a bunch of emotions. So we did difficulty. Okay, and what is difficulty or what is frustration? It is if you feel you're frustrated. Okay, so if you feel you're facing difficulties, you saw that we made a prediction about facing difficulty. At that point, the programmer can either agree with it or not agree with it. If they disagree with it, they go and press a button saying, no, I'm not facing difficulty, or no, I'm not making progress, I'm actually facing difficulty. And so that's a ground truth. How do you do it? That's a whole thesis. Okay? So this was meant to be a teaser to get that. But basically, you can use many media. You can look at the physical characteristics of the person. You can look at their facial characteristics. You can look at their posture. But that's not going to work for our homeworks of our students. They don't have cameras that are constantly monitoring them. And we used Connect for the postures. That was only in the lab. But we looked at the interaction logs, interacting with Eclipse. And the basic intuition is that when you're in difficulty, the way you interact with the programming environment changes. And there's a bunch of people at CMU, Fogarty and Hudson, who similarly found the interruptibility emotion, just looking at interaction logs. So that, to me, is the one that's really going to, at least today, we've got a technology work. Okay? But I showed you a table there. There's a bunch of papers. You Google for emotion detection, and there's a lot of papers on affect computing. Yeah.
Have you considered in the framework what it means to have emotions across people? Like you had Alice helping Bob. Did you also instrument Alice's emotion?
So that's my point. This is not. So I wanted to just be very clear here. So we've done work on emotion detection, on attention detection, and difficulty detection. We haven't put them all together. This is my proposal. Okay, so this is what I'm saying we should work on. And no, we haven't gone to that extent. And that is what I'm saying we should do. We should look at it in a general way where we should be looking at multiple emotions interplaying with each other from a use point of view. And from an implementation point of view, I'd love to go and factor out that's common among these techniques, because like I said, I just mentioned to you 2 pieces of work, both of which processed Eclipse logs to detect some emotion. Surely there's some way to unite them, and that's, I don't know what it is, but I'm just saying surely there's a way.
You mean your firm Alice is a human, or Alice is also an automatic generator of health documentation?
Okay, so that's another thing I would love to do, okay? Which is, and I think we're going to see something about screencasting from you. That might actually be helpful there. So, this is not going to, I gave you an example of teaching, okay, where this could be useful. By the way, a lot of research in collaborative software development shows that the reason why the productivity of distributed teams is lower than that of co-located teams is because there's less detection of difficulty and less help, and as a result, people don't go out of their way to help people. So this has application in industry. I don't sit in an industry organization, so I can't easily go and conduct these experiments, which I did when I was on sabbatical at Microsoft. So if you're going to do this for teaching, already we teachers are overburdened with lots of people, and so helping people when they don't even ask for help is an extra burden. So wouldn't it be nice if the way I helped you could be used to help somebody else who has the same difficulty? Maybe not doing screencasting, because that might give the solution away, but maybe providing some abstraction. And that's a challenge. That will work for the other person. Okay? But certainly if you're going to recommend certain web pages, that can be done, that can be done literally, because that hopefully doesn't have very private information.
Okay, we'll take one more question.
There's 3 candidates here, you choose.
Chris, that's the most fancy.
So I have a simple example. When I'm teaching a class with 100 students in it, no one asks a question except when I'm walking right by them. I'm wondering about this lifetime of like, I'm facing difficulty and there's this opportunity for maybe resolving it. And so I'm wondering about if you detected frustration, difficulty, and you had to broadcast it, like what's the limited lifetime you have? And this kind of those other cues and social aspects that are involved.
So I'm not sure I understood your question. One of them, you said that, look, there's lifetime that, at some point that emotion fades away, right? It's irrelevant because you've already solved the problem or you left computer science.
That's part of it, but it's kind of like, your whole system is you flag, I need help, right? So,
no, you don't flag. And Andrew's research has shown that people are, at least, we keep quoting it, I don't know whether you say it or not, that people are often late to ask for help, especially novices.
That's exactly my point. So that in the classroom setting, there's something about that cue when you're walking by that they will ask for help, right? So I was wondering about connecting those two.
Okay. So the idea here is that I don't have to walk by you. I can sense it. And I don't have to walk by you. So maybe I'll walk by you because I read your eyes, I read your face. And here I don't have to read your face, I just get told by the system. And then I say, do you need help? Exactly what Jason did in his class. That there were these people programming away, and the system would say that they're facing difficulty. He'd say, do you need help? They said, yeah, thank you for asking. And he'd get into a dialogue with them. And so this is making it scale. Okay? Scale in the sense that I don't have to monitor each one of you, but I do have to help the ones who are in difficulty. If I taught well, there won't be many of you facing difficulty. But if it's a MOOC, that's still too much for me, and that's where I want automatic help. Okay.
Yeah, great. Thank you, Prasun. Next up, we have David Socha talking about Compare as a problematic unit of analysis for pair programming.